Hi there, Joshua here. Yeah. Now, don't maths teachers make maths confusing? A bit guilty myself. I remember at school, my maths teacher tried to teach us about circles using a picture of an apple pie. What do you mean you don't understand, Joshua? To find the circumference of the pie, you multiply the diameter of the pie by pi. Let's get on with the lesson. Right, so welcome to this lesson on inequalities, regions on a grid. So I'm going to be sort of drawing lines on these grids, and I'm going to be shading the regions either side of those lines, and I'm going to be using inequalities to describe those regions. So let's start with the line x equals 3. X equals 3, what does that line look like? Well, if you're not sure what it looks like, you can actually get an idea of what it looks like by sort of finding some points that satisfy that rule. So remember, every point has an x-coordinate and a y-coordinate. Points on this line just have an x-coordinate of 3. So just choosing the obvious ones like 3, 1, 3, 2, 3, 3. 3, 1 is over here, 3, 2, 3, 3. And you could keep going, 3, 0, 3, 100. They're all in line. So the line x equals 3 is just the line through all these points. Looks like that. So any point on this line is an x-coordinate of 3, and that's why it's called x equals 3. Now what can we say about the x-coordinates of points on this side of the line, sort of on the left of the line, over here? What can we say about the x-coordinates of those points? Well, points on the left-hand side of the line all have an x-coordinate less than 3. So we can label this whole region x is less than 3, just like that. And what about points on the right-hand side of the line? What inequality can we use to describe that region? Well, points on that side of the line all have an x-coordinate greater than 3, so we can just label the region x is greater than 3. So you've got x equals 3 is the line, x is less than 3 on that side, x-coordinates are greater than 3 on that side. Right, let's move on to the next grid. Just going to draw a couple of horizontal lines. Like so, this top line goes through 2 on the y-axis. This line goes through -1 on the y-axis. So what's an equation for this line? What's an equation for that line? Well, it's a line where all the y-coordinates are 2. So we could label it y equals 2. What about this line? What's an equation for this line? Well, it's a line where all the y-coordinates are -1. So we can label it y equals -1. Now, what inequality can we use to describe points in this region? This region up here. The points in that region all have a y-coordinate greater than 2. So we can call this region y is greater than 2. Points in this region. What inequality can we use to describe this region? Well, points in that region have a y-coordinate less than -1. So y is less than -1 is that region. Now what about the region in between the two lines? So what about this region here? What can we say about points in this region? Well, to be in that region, you've got to have a y-coordinate greater than -1, but less than 2. So y is greater than -1, but less than 2. That's the inequality for that region. Right, let's move on to this grid down here. So let's shade the region now. Let's shade the region x is greater than 1, but less than 4. So we're looking for points where the x-coordinates are greater than 1 but less than 4. So to shade that region, we first of all need to draw the boundary lines. We need to draw the line x equals 1 and x equals 4. X equals 1 and x equals 4 we need to draw. So x equals 1 is just a vertical line going through 1 on the x-axis. Just the line where all the x-coordinates are 1. Let's mark it like that. It's going through 1. And x equals 4 is another vertical line going through the x-axis at 4. Just the line where all the x-coordinates are 4. So this is the line x equals 1, this is the line x equals 4. We're looking for points with an x-coordinate greater than 1 but less than 4. So those are going to be the points in between. So this is the region that we want. It's just all the points in between those two lines. That is the region x is greater than 1 but less than 4. Right, let's move on to this grid over here. So let's shade the region of points where x is greater than 3 and y is less than 5. So we're looking for points with an x-coordinate greater than 3 and a y-coordinate less than 5. Again, we first of all need to draw the boundary lines. We need to draw x equals 3 and y equals 5. Just replacing those inequality signs with an equals sign. Let's draw x equals 3 and y equals 5. Actually, I'll just put it a bit further down and then we'll decide which region to shade. I'll just write it over here, y equals 5. So x equals 3 is a vertical line going through 3 on the x-axis. So let me draw that. That's the line x equals 3, going through 3. And y equals 5, that was x equals 3, is just a horizontal line going through 5 on the y-axis. So that's the line y equals 5. And we're looking for points where x is greater than 3 and where y is less than 5. So we want points where the x-coordinate is greater than 3. So that's going to be to the right of this line. And where the y-coordinates are less than 5, that's going to be below this line. So the region we're looking for is this region over here. Right, for the last grid I'm going to draw a region and see if you can think of two inequalities that describe the region. So I'm going to do a line like that, and a line like that. And I'm going to shade this region here. So this line, the vertical line goes through -2, and the horizontal line goes through 3. So can you think of two inequalities that describe this region? Well, again, let's write down the equations of the lines first. So this line is a horizontal line going through 3. So it's y equals 3. It's the line where all the y-coordinates are 3. This is a vertical line going through -2 on the x-axis. So it's x equals -2. So on the line all the x-coordinates are -2. Right, so the points in our region have an x-coordinate less than 2, because they're to the left of this line. And they've got a y-coordinate greater than 3. Because they're above this line. So that the inequalities are x is less than -2 and y is greater than 3. Those are the two regions that describe the inequality. Sorry, those are the two inequalities that describe the region. So we've just looked at horizontal and vertical lines and the regions associated with those lines. Let's move on to sloping lines now. So let's start with y equals 2x. So what does that line look like? Well, if you have to graph an equation of the form y equals something x plus something, and this is kind of that form, because you could think of it as y equals 2x plus 0, if you like, then these numbers tell you exactly where the line's going to be. The number in front of the x, we usually use m for that number, and that tells you the gradient of the line, how steep the line's going to be. And the number at the end, which we usually use c for that number, tells you the y-intercept, where the line crosses the y-axis. So our line is y equals 2x plus 0, if you like. So it's got a gradient of 2 and a y-intercept of 0. So it's going to go through 0 on the y-axis, like that. And it's got a gradient of 2, which just means it goes right one up 2, right one up 2, right one up 2. So right one up 2, right one up 2, right one up 2, right one up 2. There's some points the line passes through. Let's draw the line. A bit wobbly, but it looks something like that. That's the line y equals 2x. Now that's the line. Can we use inequalities to describe the regions either side of the line? Well, if I pick an arbitrary point on this line, if I just pick a point there, let's say, this is the point 3, 6. Now, of course, because it's on the line, it's going to fit that equation. It's going to fit the equation of the line. Y does equal 2 times x. 6 does equal 2 times 3. And that's true of any point on the line. Any point on the line is going to fit that equation. But what about points below the line? What can you say about those points? If I move down 1 unit to the point 3, 5, this point's not on the line, so the x and y coordinates are not going to fit that equation anymore. But is the y coordinate more than 2x, or is the y coordinate less than 2x? Well, I haven't changed the x-coordinate by going down. I've only changed the y-coordinate and made it smaller. So the y-coordinate is now going to be less than 2x, because 2 times x, 2 times 3 is still 6, but y isn't 6 anymore, it's 5. So any point below the line, for any point below the line, the y-coordinate is going to be less than 2 times the x-coordinate. Because when you go down, you're making the y-coordinate smaller. So this region of points, the y-coordinate is going to be less than 2 times the x-coordinate. So y is less than 2x for points in that region. And then if we go up, let's say go back to 3, 6 on the line, and then we go up 1 unit to 3, 7. Hopefully you can see that now y is greater than 2x, because we've gone up and we've made y 1 bigger. 2 times x is still 6, because x is still 3. But now y is 7, we've made it bigger, so y is greater than 2x for this point. And for any point above the line, the y-coordinate is going to be more than 2 times the x-coordinate. So here y is greater than 2x. So for points on the line, the y-coordinate equals 2 times the x-coordinate. Above the line, y is greater than 2x. Below the line, y is less than 2x. Right, with that in mind, let's do another one. Let's shade the region y is greater than x plus 2. So we're looking for the region of points where the y-coordinates are greater than the x-coordinates plus 2. So before we can shade the region, we need to draw the boundary line, which is just y equals x plus 2. Just replacing the inequality sign with an equal sign. We need to draw that line first. Now luckily it's in the form y equals something x plus something. So if you think of it as y equals 1x plus 2 if you like. So the gradient is 1 and the y-intercept is 2. That means it goes through 2 on the y-axis, so we can use that as a starting point. It goes through 2. And the gradient of 1 just means it goes right 1 up 1, right 1 up 1, right 1 up 1. So it's a diagonal line going through 2 on the y-axis. So this is y equals x plus 2. Now we need to shade the region y is greater than x plus 2. Region of points where the y-coordinates are more than the x-coordinates plus 2. So is that going to be above the line, or is that going to be below the line? Well, for any point on the line, y equals x plus 2. So if we want the y to be greater than x plus 2, we need to go up, because when you go up, you make the y-coordinates bigger. So any point up there, the y-coordinate will be greater than x plus 2. So the region we want is the region above the line. Just to give you an example of that, so as I said, on the line, the y-coordinates equal x plus 2. For example, if you pick a point on the line, like 0, 2, this point here, you can see that the x, that's y, you can see that the y-coordinate equals the x-coordinate plus 2. 2 equals 0 plus 2. But as soon as you go above the line, for example to, I know, let's say this point 0, 5, here y is going to be greater than x plus 2, because x is still 0, so x plus 2 is still 2, but y isn't 2 anymore, it's 5. We've made y bigger, so the y-coordinate is greater than the x-coordinate plus 2. So hopefully that example is clear. Right, let's do another region. Let's do x plus y is less than 5. Let's shade that region. Well, that looks a bit weird, because in all the other examples y has been the subject, but here y isn't the subject. So let's make y the subject. I think it'll be a bit easier to draw the line and a bit easier to shade the region if y is the subject. So let's do that. So to make y the subject, you just subtract x from both sides, like so. And you get y is less than 5 minus x. So I'm going to think of this inequality in that form, because it'll be a bit easier to draw the line and a bit easier to shade the region. So we want to shade the region of points where the y-coordinates are less than 5 take away the x-coordinates. A bit confusing. We need to draw the boundary line though first. The boundary line for this region is y equals 5 minus x. Right, so what does that line look like? Well, it is in that form. I mean, the x term's at the end, but it is in that form. You can think of it as y equals 5 minus 1x. So the gradient is minus 1, and the y-intercept is 5. So y-intercept is 5, let's use that as a starting point. And a gradient of minus 1 just means it goes right 1, down 1, right 1, down 1, right 1, down 1. So it's going to look like that. So this is the line y equals 5 minus x. We want the region of points where the y-coordinates are less than 5 minus the x-coordinates, where y is less than 5 minus x. So is that going to be above the line, or is that going to be below the line? Well, for any point on the line, y equals 5 minus x. If we want y to be less than 5 minus x, we need to go below the line, because when we go down, the y values get smaller. So this is the region that we want. This is the region y is less than 5 minus x. Again, just to make that clear, I'll just do it with an example. So I said on the line y equals 5 minus x for any point. For example, for this point here, 0, 5, you can see that the y coordinate is equal to 5 take away the x coordinate. 5 equals 5 minus 0. But as soon as you go down, and let's pick a point, let's say 0, 2, you're making the y coordinate smaller. So now the y coordinate is going to be less than 5 minus x. Because 5 minus x is still 5 minus 0, which is 5. But the y coordinate's not 5 anymore, it's 2. So for any point below the line, y is going to be less than 5 minus x. So I hope that's clear. We'll do one more example over here. Let's do, I think it was x minus y is less than 3. So we're looking for points where the x coordinate take away the y coordinate is less than 3. Again, it looks a bit odd compared to the other ones we've done because y isn't the subject. So again, I think I'll make y the subject. You don't have to do that. But for me, it just makes it a bit easier to draw the line and to shade the correct region. Now, there are a couple of ways to make y the subject here. I'm going to do it by adding y to both sides as the first step. And that'll give me a plus y on the other side. So if I do that, you get x is less than 3 plus y. And then to get y on its own, you just take away 3 from both sides. Take away 3, take away 3. You end up with x minus 3 is less than y. Or written the other way round, with y as the subject of the sentence, y is greater than x minus 3. So I'm going to think of this inequality in that form. So we want to shade this region. We're looking for points where the y coordinate is greater than the x coordinate take away 3. So we first of all need to draw the boundary line, which is just going to be y equals x minus 3. So y equals x minus 3. So what does that look like? Well, again, you could think of it in that form. If you imagine a 1 there, it's just y equals 1x minus 3. So it's got a gradient of 1 and a y-intercept of minus 3. So it goes through minus 3 on the y-axis. And as I said, a gradient of 1 just means right one up one, right one up one, like that. So that's what it looks like. That's the line y equals x minus 3. And we want points where the y coordinate is greater than x minus 3. So is that going to be above the line or below the line, do you think? Well, for any point on the line, y equals x minus 3. If you want y to be greater than x minus 3, you have to go above the line. So the region we want is above the line. So it's this region here. Y is greater than x minus 3. When you go up, you're increasing the y values, so it's above the line. Again, we can just check that with an example. This point, 0 minus 3, is on the line. So it fits this equation perfectly. Y does equal x minus 3. Minus 3 does equal 0 minus 3. But as soon as you pick a point above the line, like for example, I don't know, 0, 5, let's say, now the y coordinate is greater than x minus 3. Because in this example, x is still 0, so x minus 3 is still minus 3. But y isn't minus 3 anymore, it's 5. So y is greater than x minus 3 for any point above the line. Right, so a couple of slightly harder questions now to finish off. Let's have a look at the first one. It says, show the region of points that satisfy these 3 inequalities. The inequalities are y is greater than minus 2, y is greater than x, and x plus y is less than 4. So we're looking for points that are in this region, but they've also got to be in this region, and they've also got to be in that region as well. So we're basically looking for the intersection of those 3 regions. We're looking for points in all 3 regions. Now if you notice here, y isn't the subject, so I'm going to make y the subject. I think it's a bit easier to draw the line, as I said, and a bit easier to choose the correct region. So to make y the subject, I'm just going to subtract x from both sides. So you get y is less than 4 minus x. So this inequality, I'm going to think of it in that form. Now before we can shade the correct region, we've got to draw the boundary lines. So we've got to draw the boundary line to this region, which is y equals minus 2. The boundary line to this region is y equals x, and the boundary line to this region, thinking of it in that form, is y equals 4 minus x. Y equals 4 minus x. So let's draw those three lines. So starting with y equals minus 2. So what does that line look like? Well, it's just a horizontal line through minus 2 on the y-axis. The line where all the y-coordinates are minus 2. What about the line y equals x? What does that line look like? Well, that's just the line that contains the points where the y-coordinates equal the x-coordinates. So, for example, the point 0, 0, the point 1, 1, 2, 2, 3, 3, and so on. So it's just a diagonal line going through the origin. It's something like that, just missed there. So it goes through the origin, that's it, y equals x. And the line y equals 4 minus x, it's in the form y equals mx plus c, although the x term is at the end. If you think of it as y equals 4 minus 1x, you can see that the gradient is minus 1, and the y-intercept, the number on its own, is 4. So we can use 4 as a starting point. And a gradient of minus 1 just means it goes right one, down one, right one, down one. So it's a diagonal sort of sloping line. So it's going to be like this. So it goes through 4 on the y-axis. Because it's sloping down diagonally, it's also going to go through 4 on the x-axis. So I'll mark that in as well. I'll just label the line as well. So this is y equals 4 minus x. Right, so now we've got to shade the correct region that satisfies all three of these inequalities. Notice the boundary lines, they split the grid into lots of separate regions. So just to help, I'll label those regions with letters, just so we can see them. So we've got this region here, I'll call it A, B, this region here C, D, E, F and G. And we've got to decide which of those 7 regions satisfies all three inequalities. So maybe we can eliminate some as we go along. So let's start with the first inequality. So y is greater than minus 2. We're looking for points where the y-coordinates are greater than minus 2. So this is the line y equals minus 2. So points where y is greater than minus 2, are they going to be above this line or below the line? Well, they're going to be above this line. To have a y-coordinate greater than minus 2, you've got to be above this line. So we can eliminate straight away E, F and G. The region's got to be above this line. So that's eliminated 3 of them. We're down to 4 now. So let's look at the second inequality. It's y is greater than x. So on this line, y equals x, the y-coordinates equal the x-coordinates. Points where the y-coordinates are greater than the x-coordinates, are they above the line or below the line? Well, if we want y to be greater than x, we're going to have to go above the line. Remember, when you go up, the y values increase. So we know it's points that are above this line. So it's got to be region A or B, can't be C or D. So we can eliminate those. Finally, we're looking for points where y is less than 4 minus x. So on this line, points have, so y equals 4 minus x, the y-coordinates equal 4 minus the x-coordinates. If we're looking for points where y is less than 4 minus x, are they going to be above the line or below the line? Because it's y is less than 4 minus x, it's below the line. So it's got to be region B. It can't be region A, which is above the line. So that just leaves region B. So that's what it's got to be. I'll just shade this region. So the region we're looking for is all these points. And it goes off forever in that direction. But that's the region. Now it's always a good idea to check that you've got the correct region by picking a point in that region and then just checking that the point satisfies these 3 inequalities. So let's pick a point in this region. Let's pick a point we know is in the region. I'm just going to pick this one here. 0, 2. The point 0, 2. And let's just check that it satisfies all 3 inequalities. That way we'll know we've shaded the correct region. So the first inequality is y is greater than minus 2. So is the y-coordinate greater than minus 2? Yes, it is. The y-coordinate's 2, and 2 is greater than minus 2. So it satisfies that inequality. Let's move on to the next inequality. Y is greater than x. So is the y-coordinate greater than the x-coordinate? Yes, it is. 2 is greater than 0. Okay, let's just check the last inequality. X plus y is less than 4. is x plus y less than 4? When you add up the coordinates, do you get a total less than 4? Yes, you do. 0 plus 2 is 2, which is less than 4. So since this point satisfies all three of these inequalities, that means we shaded the correct region. So it was region B. Right, moving on to this question now. Write down three inequalities to describe the shaded region. So a region has already been shaded, and we've just got to write down three inequalities like this to describe the region. So what can we say about points in the region? Well, again, before we write down the inequalities, let's write down the equations of the boundary lines. So what's the equation of this line here? Or an equation for that line? Well, it's the line that goes through -1 on the x-axis, so all the x-coordinates are -1, so it's x equals -1. What can we label this line? Well, it's a line where all the y-coordinates are 2, so we can call it y equals 2. And what about this sloping line down here? What's an equation for that line? Well, let's think of it in terms of y equals mx plus c. So I'll just write y equals something x plus something. It's a straight line, so the equation can be written always in that form if it's a straight line. And the y-intercept is 6, isn't it? It goes through 6 on the y-axis, so we can say it's 6 there. But what's the gradient? Well, it goes right 6, down 6 to get from this point to that point. Right 6, down 6 is the same as right 1, down 1, right 1, down 1, right 1, down 1, and so on. So the gradient is -1. So we can write y equals -1x plus 6, or just -x plus 6. So that's the equation of that line. And now it should be fairly straightforward to think of the three inequalities that describe that region. So this is the line x equals -1. Points in this region are to the right of that line, so they're going to have an x-coordinate greater than -1. So that's our first inequality. X is greater than -1. If we look at this boundary line here, on this line all the y-coordinates equal 2. Our region is above that line, so for the points in our region, the y-coordinates are going to be greater than 2. So that's our second inequality, y is greater than 2. And looking at this boundary line, so on this line, y equals -x plus 6. So our region is above that line. So for points in our region, the y-coordinate is greater than -x plus 6, because it's above the line. So y is greater than -x plus 6. So those are the three inequalities that describe the points in that region. So that's it.